All right, let's go ahead and take a look at number 2 on page 38, where we're looking at the question that states sound travels at about 1,088 feet per second. So 1,088 feet per second at 32 degrees Fahrenheit in dry air at sea level. Okay. 32 degrees Fahrenheit, dry air at sea level. Okay. So part A is asking us to write an equation to find the distance traveled by sound for any number of seconds. So notice how in part A it's just talking about the equation for the distance traveled by sound. It has no reference to the 32 degrees Fahrenheit. So as we see here, we don't necessarily need that portion. So we'll just ignore that for right now. But what we will need is we will need this, obviously, this 1,088. Let's make that a little bit more clear. 1,088 feet per second. So let's go ahead. We said write an equation. So let's go ahead and define a variable. So write an equation to find the distance traveled by sound for any number of seconds. So let's let S equal the number of seconds. And we'll let, since distance was measured in feet, we'll let equal the number of feet. So we can say F, because that's our resulting goal. Remember, we're trying to determine the distance given the number of seconds. And we said that it travels 1,088 seconds here. Now, if we know the number of seconds, would we be able to determine how many feet? Because it travels in feet per second. Now, I want to make something here. It's not a matter of, dividing by F and not having the same unit here. Remember that 1,088 represents, how do I want to say? It represents how fast sound will travel in 1 second. Here we go, 10,088 feet in 1 second. Typically, you might see it written like this. But remember that anything over 1 is just itself. And also the same fact that we don't necessarily write 1 as a coefficient, even though it's not really a coefficient here. We could think of maybe reducing down, and anything over 1 is just itself, and how this kind of coming back to what we have here. It's just a little cursor of how that looks. So if we were to just, this is a little aside from this. If we were to include the units, now you don't necessarily include the units here, but I'm just going to do it for the purposes of what we're looking at. Notice here that these seconds will reduce off, and we'll be left with, just feet. Remember, we said that F represents feet on both sides. That'll become more apparent as we actually plug in numbers. So let's say if we had 2 seconds. So F would equal, these S's reduce, and we have, this would be 1088 feet times 2. And then here we would just multiply. So we need a little extra room here to do this one. So here we have and notice how in this case those units stay. And they actually do represent what F stands for, number of feet. Notice how that works. So this is just a little bit of extra to this in reference to how we can find our solutions with the, excuse me, with the units. But let's go ahead and focus here on the part A. It only asks us to find the equation. There it is. And let's go ahead and look at part B now, where we have to make a table to find the distance sound travels and then graph. So let's do, let's see, so S is going to be like our X, F is going to be like our Y. And the reason I know that is because typically you're going to have that Y by itself on this one side of the equal sign. In this case, we have F, so F is going to be like our Y. It's also our output. Remember, our input is what we're plugging into the equation. We're plugging in seconds. If you recall, X is our input. So let's see, we're doing 0, 1, 2, 3. First one's going to be pretty easy. If you plug in 0, 0 times anything is 0. If we plug in 1, 1 times anything is itself. We actually did 2 already, so this is going to be 2176. And let's do times 3. Okay, so 4, 2, 6, 2, 2, 3. And you can actually do that too by doing what you had before and adding to this, so you still get the same solution. Good. All right, so here's our table, and for the purposes of labeling, I'm going to signify each one of these with a letter, capital letter, and you'll see where that comes into play in just a moment. So let's actually go over to here, and let's create our coordinate plane. We're actually only going to need the first quadrant, so I'm going to make that the largest. Label our graph. This was F. This was S. I'll use even numbers here. And let's go. There we go. Okay. I'm going to go by increments of 500. Okay, so that should be good. We don't, you see our largest number here. We don't go past 3,500, so there's no reason to do so. Our first one was A00 whenever 0 seconds occurred. Let's see, 1 second we were 1088, probably about here. B. Let's see, 2. We said it was 2176, so maybe about here. And then finally our last one said 3 was 3264. So maybe about there, D. And then if we were to draw these, the graph would look something like this. Now the question I would have for you is, what issues lie in doing a graph like this freehand? I think it's pretty evident. So why don't you go ahead and take a moment to think about that. Okay, so you thought about it. Now, I'm looking at it. Here are some things that stick out in my mind. Maybe you have something different. If you do have something different, feel free to drop me a line in the notes column when you're filling out your homework. And I can get a little bit of better read. Leave me a comment. Let me know, hey, this is another thing that we would have an issue when we're graphing freehand like this. Without the use of graph paper and proper tools, such as a ruler or whatever it might be, notice how these tick marks aren't evenly spaced. Notice how these axes aren't straight themselves, thus leading to another piece. We're not graphing whole numbers. Notice here I spaced each one of these on the f-axis for what it's worth in this particular question. I spaced them by 500. Now, if I space them by 1, with such large numbers like this, it's going to be very difficult. But even if I were to space them by like 50 or 100, you're still not going to get perfect, accurate points because you're still going to end up in between your tick marks. Still going to end up between your tick marks. The best way to go about doing this is by using that graph paper. But even when using graph paper, with such large numbers, you're still going to have a level of error associated with your work. So all you can do is just get it as close as you can. Notice here, we did everything properly, but we were as accurate as possible, but we weren't exact. It's going to be hard to be exact when you're not using the necessary tools to help you succeed in what you're seeking to do with this. Well, that's all we have today for this particular lesson. Thank you very much. Any questions, feel free to let me know.